solar flares causing blackouts in various regions of the world, including Australia, Asia, South America, with more intensity hitting the countries furthest south on the planet, in addition to a sequence of asteroids passing close to Earth and meteorites discovered hours before, hitting areas with high population density, with most of these occurrences happening in recent months. What do all these events have in common? The reality that, despite appearing calm, space is a very dangerous place, and now we are, through technology, managing to monitor and prevent these events with the maximum possible advance notice. But what startled the scientific community this week in particular was the explosion that hit Brazil in such an unexpected way that until today, it was not considered possible, indicating that we may be much more exposed to space hostility than we imagined.
A massive solar storm hit the Earth last night, and it is accompanied by another one that is arriving any moment here.
Therefore, the question is not if, but when we will have to deal with these events in the future, as they have happened countless times in the past, and it is only a matter of time before they happen again. On February 9, 2020, the Sun had the second largest solar flare in years, causing a shortwave radio blackout across Africa and South America. The solar flare occurred in the morning local time and was detected by various telescopes and space probes studying the Sun and its phenomena, considered the second largest ever recorded since 2003, when the so-called Century Storm occurred, causing damage to satellites, power grids, and navigation systems worldwide. What's most curious is that the explosion was so powerful that its shockwave reached the Earth, even though it occurred on the opposite side of the Sun. This is very rare, and only happens when the solar eruption is extremely strong and fast, capable of generating a coronal mass ejection that propagates in all directions. When this explosion reaches Earth, it can cause geomagnetic storms, which are variations in the Earth's magnetic field that can affect power grids, satellites, and navigation systems. With this happening on the 9th, even though it was on the opposite side of the Sun, having managed to provoke a geomagnetic storm of a level considered moderate, with all its force pointed towards us, could lead us to a much worse situation than what happened in 1859 with the Carrington event, which also occurred during the peak of the solar cycle, where such events occur more frequently. The Sun, despite being calm when compared to most stars in the universe, undergoes significant changes in its age phases. With much study and research, it was discovered that it reaches its peak during an 11-year cycle. During this period, the Sun has more spots that ultimately lead to these eruptions and coronal mass ejections. The solar storm classification scale includes the following classes in increasing order of intensity:
Class A, Class B, Class C, Class M, and Class X.
In addition to this scale that classifies the intensity of solar flares based on the amount of X-ray radiation they emit, we also have the G-level scale that classifies the intensity of geomagnetic storms caused by these flares, ranging from G1 to G5, with G5 being the highest. A G5 level storm is the most severe and can affect communication and power systems. In 1859, during one of these solar activity peaks, the modern world witnessed the largest storm ever recorded in history, which had impressive effects on Earth. Causing a G5 level geomagnetic storm, which is the most severe known. However, despite its strength, it is not known exactly what the class of this explosion was, as this scale was developed after this event. At the time, the storm affected telegraph systems, which were the main form of communication at the time. Some poles even caught fire, and some operators of these networks received electric shocks. If a solar explosion of this magnitude were to hit the Earth today, it would be infinitely more disastrous than the Carrington event, as our society depends much more on technology and electricity. Such a situation could still cause blackouts in power grids, which are vital for the operation of hospitals, industries, transportation, and public services, causing a collapse in infrastructure and the economy. Due to this, since then, various government space agencies have begun to monitor solar activity. Currently, NASA's Solar Parker, China's Huafu-1, and the European Union's Solar Orbiter constantly monitor these activities, with some of them being only 10 million kilometers away. This is an incredible feat considering the hostility of the region. Even more so when we compare how much we feel the effects of the star, even though it is about 150 million kilometers away. However, the bigger problem is that we only have the ability to predict these explosions to minimize their risks as much as possible. With early warning, it is possible to avoid the harmful effects of solar flares on spacecraft and astronauts. And this point is being taken very seriously in the Artemis program since the direct exposure of this explosion on the Moon, a place where there is no atmosphere to protect astronauts, is game over for any living being directly hit by this explosion. But that doesn't mean we are free from this threat. Scientists estimate that there is a 12% chance of a Carrington-like event occurring in the next 10 years, and we are currently close to the new solar peak predicted for 2025, which is expected to be stronger than the previous one and was considered the weakest of the century. Therefore, it is important to monitor solar activity and prepare for possible space emergencies. If the unpredictability of our sun weren't enough, we also have a multitude of asteroids passing close to Earth. Over the past few years, we have been detecting many of them shortly before they hit the planet. This happens because our detection technology has improved significantly in the last decade, leading us to detect more and more dangerous objects. However, despite this technology being quite advanced, we still have great difficulties in detecting all smaller objects. The most recent discoveries involve the 2023 NTI, an asteroid about 60 meters in diameter that passed 125,000 kilometers from Earth on July 13, 2023, and it was only discovered 2 days after its passage. Another recent one involved the 2024 CY1, which passed just 121,000 kilometers from Earth on February 12, 2024, just 3 days before this publication. Although both of them were above 100,000 kilometers away, it is still a very close distance when we talk about space, especially when we consider that the Moon is about 384,000 kilometers away. That's it, folks. Share with us what you think about this, including if you have any doubts. And if you're not yet part of our community, leave a like and subscribe, as this is essential for the channel to gain prominence, which consequently helps us create more content like this. Thanks a lot and see you next week.